The simplest possible case in terms of interactions is when there aren't any. So we're going to try to devise a situation in which there is, when an object experiences as few interactions as possible. And that's why we have brought the dry ice. Let me show you how this works. Which side of the same we're using? Why is it kind of spooky? It's moving noiselessly, right? Why is that weird?
There's no interaction.
Well, there's no interaction with the table. How's that happen? Yes, exactly right. What's this thing doing? What's a better word for that? Sublimating? Remember that? Okay. That means evaporating directly from a solid to a gas. Because carbon dioxide, which is what this is, has no gaseous, no solid, no liquid state. I tried all three before I got the right one. So there's actually, but that happened on all four sides, all 4, 5, 6, 7, 8, 9, 10. But including the creation of a layer of gas underneath that actually it rides on top of, like a little airlock, insulating it from the table. There's actually no contact with the table, and therefore no interaction. And so this gives us a wonderful opportunity to explore how things will move when they are not subject to or not experiencing any interaction. Now, most of the time, actually, this is experiencing interaction with water. Me, yeah. I'm interacting with it almost continuously, in fact. But if I can stop doing that and just let it go for a while, we can see what it would do with no interaction. And here's where I will need my volunteers, because we do not want it to fall off the table and stuff. So if you could get your gloves on, come on up. I thought you gave it to Victoria.
I thought you gave it to her, so I was
Oh.
okay.
She asked for it.
It's okay. It's okay.
Alright, so why don't you get on this side so everyone can still see? And what we're going to do is we're just going to send this down the table. I'm going to briefly interact with it, and then try to stop interacting with it as soon as possible, and allow it to move down that way. And Anton is going to catch it and send it back toward me. You two gentlemen are responsible to make sure it does not fall off the table along the way, in either direction. Okay? Okay. Well, they can reach it. They're good. Okay. Star Atlas. Okay. You ready? Okay. We're just going to do it 3 more times. Just watch what you see, and I'll give you a specific look. Okay. Now, ask yourself as you're watching it, what model of motion do you observe this dry ice following or doing? Let's put it back in a minute so we can talk about that. You guys can see for a second. What's your answer, independent? What'd you say? You say dependent in constant velocity. Why? It seemed like it was going at a constant speed. Okay. Who agrees with that? Who disagrees with that? So it's unanimous. Okay. Can you give me some specific evidence for why you think it was going at a constant speed? What does that look like?
Doesn't look like it's
slow down at all. Okay,
Except for the accelerator, or I got it accelerated and all.
so it didn't look like it got faster or slower, except for you.
Yeah.
Okay. All right. Do you think we need to verify the motion next, or is it pretty clear? What? I should do it. Okay, sure, we'll get there. Just to be absolutely sure. Doesn't like that other side. Huh? That noise is hideous. Okay, we can have someone run the computer and someone else hash. Go ahead, sorry. I'm sorry? Did he get unplugged? Alright, go for it. You think you'll have to back up that way or this way? Sure, it's looking smart.
I'm not responding at the moment. If you put just a ton of weight on top of that, will it still not have an interaction?
Okay. You want to do it again?
Yeah, I'm scared.
Okay, wonderful.
Yeah, I love
Okay, zooming in on the relevant portions of this here. Constant velocity? How do you know? Okay. Constant slope, and this is a constant value right there. Some bad data from people in the hands in the way and stuff, but the general trend is constant. And we see it on the way back to there. Not quite as good, but it is still a constant trend. All right, so that confirms that. All right, I want you to think about, since we're looking for this notion of this interaction thing, you kind of looked at what happens here without this interaction. Let's break this into, I think there's 5 moments in this. Let's explore the 5 different moments or intervals that are going on. What do you think I'm thinking when I say 5 moments?
Remind me.
Start the first thing when it hits the middle, the second part, and then stop.
Good. Okay. So first part is when I push it. At that point, am I interacting with it? Okay. Beginning of the first table. And then what's after that? What's the next kind of section?
It's just going on the first table.
So after I have pushed it. At that point, am I interacting with it?
No.
Okay. What's the next moment of interest? Okay. Is there an interaction involved there now?
Yeah, it's stable.
Why does that happen? I mean, isn't there this layer of air?
But if there is a different layer,
It's a thin enough layer of air that things can poke into it, they can drag it all right. Okay, so interacts with crack. Okay, and then next section? Sorry?
After the interaction.
After the crack.
After the interaction with the crack. So is there an interaction going on there? And the final moment is when? Is there interaction there? Sorry?
Yeah.
So I'm going to propose, I'm going to circle this in green and this in brown. Which other parts would you circle in green? Which other parts would you circle in brown?
Green for the.
Brian?
Green for the, fourth one, after the red.
Brown? Why, Brian?
Because, the green ones are the ones that are something interacting with the guys, and then the brown ones are the ones that are something interacting with it.
That seem a fair division of these different areas? Based on our observations, what sort of motion happened in each of those places? Ken, sorry about that. Constant velocity happened where? In all of them, all five?
The green ones.
Just the green ones? So we observed constant velocity both there and there, yes? Is that true? Leslie? Yeah? You look doubtful.
I think when you question it, like, the Northern Nether is not too much different.
When I push it, that's here.
But, yeah, no, I believe that those are constant velocities.
You believe that these are?
Mm-hmm.
Okay. Now, are these also constant velocity while I'm pushing it? And was it constant velocity when it was touching the crack? What did happen when it touched the crack? It slowed down? It is.
Yeah.
Noticeably?
Not
Not very noticeably?
But if something sort of cross interacts, that should slow it down a little bit.
I don't care what should happen. I care what I observe, right? Always want to base our models on something we observe, not what we think is going to happen. Because we want models that describe the real world, not our thought world. So let's observe it again to make sure, because we've done so much thinking, we've only forgotten our observations. So first of all, we can verify that there certainly was constant velocity there and see what we see in terms of the velocity while I'm pushing it, while Emmy Tom is catching it, and while it's interacting with the crack.